Okay, let's get going with this. So I am an energy consultant here in California. I've been doing this since 1991. I realize how old that is every now and then when I look in the mirror. And I've been able to work with architects, designers, contractors, et cetera, that have been our clients at Gable Energy, a company I own in Northern California. And sometimes describing what is it the code is trying to do and how it's doing it, and how these compliance forms are a tool. We look at them as, hey, this is what the energy code requires, but they can be difficult to understand. And what are they telling us that can help support the goals to show compliance to the energy code, but also to show compliance to other alternative programs that we are trying to participate in, or to get data out of what our modeling for the energy compliance can help support. So we'd like to go through that with you guys to be able to give you those ideas of how you can use what you're going to get every time you pay for a Title 24 calculation, and maybe what you should be requiring that energy consultant do to help support your projects and your goals. We at Energy Code ACE, we have a series of tools. Some of our favorite tools is Reference ACE, which is the digital copy of the code itself, plus all of the manuals and the materials supported by the Energy Commission for us to understand the energy code requirements themselves. Training, we have other classes I'm going to be telling you about that we do a deeper dive on this particular topic, so you can go and look for additional help. And also a lot of our offerings do have Z and CD credits like this one does today. And then our resources, we have fact sheets, trigger tables, all sorts of things, and I'll be sharing some of that. That also is going to help out with this particular topic. Everything we do at Energy Code ACE to support you, the ratepayers here in California, we are at no cost because you are helping support everything we do for this Codes and Standards program. We thank you. So let's talk a little bit about what code applies. So we are currently in our 2022 code cycle. And it's called the 2022 code cycle because that's when it's adopted. That's when it was voted upon. This is what we're going to do through the Building Standards Commission in the state of California as a statewide code. We're one of the few states that have a statewide code. Now, it will not be enforceable till the January past the adoption date. So it was adopted in 2022. But it did not become enforceable for projects that apply for permit until January 1st of 2023. And it will be the code that sets the requirements for the projects and their scopes through the end of next year, December 31st of 2025. Then we will have our 2025 code will go into effect for projects that apply for permit as of January 1st of 2026. You now know why it's called the 2025 code, because that's when it's going to be adopted, hopefully, by the Building Standards Commission, and then will become enforceable the January following, which is January 1st of 2026. So the energy code development process is very much a public process. We love to hear from the industry and have them participate as much as possible. We are in a very unique situation right now where they opened up review by the public for some of the adopted code in a second 15-day period, in which we have 15 days to provide comments on some of the language being proposed for the 2025 code cycle for us to help engage change and or understanding of how these codes apply. When we talk about Energy Code ACE, we use these colors and symbols to represent, such as our mandatory requirements. Our mandatory requirements, we use red. We use the symbol of the gavel. You have to do this because mandatory measures apply for that particular building occupancy. So single family will look differently from non-residential, which will look differently from multifamily. And these mandatory requirements are the bare minimum, and they apply. Is there a question? Sorry, not sure. I can't quite see everyone to know if someone is raising their hand and wanting to ask a question or if that's just background noise. So mandatory measures, can we mute people who are not speaking out loud? That would be great. Okay, sorry, I get so distracted. Mandatory applies across all scope of work.
I'm not considering
I'm sorry? Okay, I guess I'm just going to ignore background noise. So mandatory requirements apply across all scopes of work, whether it's new construction, the least expensive time to integrate energy efficiency, additions and alterations in which now we have existing infrastructure. And when we look at the cost effectiveness analysis of the code, the rules most often change, but not when it's mandatory. Prescriptive is where things will change based on building type, based on scope of work, new construction, additions, alterations, and will change based on what the climate zones. We have 16 climate zones in California. Is it a building feature that is going to help save heating energy for our cold climate zone? Is it a building feature that's going to help save cooling energy in our hot climate zones? This is all what happens when we develop the energy code requirements. We can use the prescriptive method to show compliance, or we can use the performance approach for the features within the conditioned envelope of the building only. The performance approach option will not support any energy use features that are outside the conditioned envelope and what's serving the conditioned envelope. So that'll include, well, the envelope itself, mechanical systems, lighting within that conditioned space, and then any renewable systems that are supporting that energy use within the conditioned space. So California is talking a lot about zero net carbon design these days. So we have some assembly bills that have been adopted to help support where we'd like to go in California, considering our carbon footprint and carbon intensity of our different products that we use. And based on Assembly Bill 2446, we are seeing things roll out to licensed architects in California. You guys are all aware now, to be licensed in California as an architect, you do have to meet certain continuing education units, such as what this class helps support, so that you have a deeper understanding of what we're trying to achieve in California and how we're going to get there. We also have new embodied carbon requirements of CalGreen, that's Title 24, Part 11, that went into effect July 1st of this year, just a couple months ago, and that will apply to non-residential and school buildings. You should be aware of that. And we have more aggressive electrification and renewable energy source measures within the energy code for this current 2022 code cycle, and it's going to be more robust in 2025. It'll be even more robust in 2028 as we meet this future goal of 2035 of having a 40% reduction in greenhouse gases. When we talk carbon, there's different parts of carbon. We have the embodied carbon associated with the materials that we're using and what it takes to get that material on site and its impact. That is covered under the CalGreen Title 24 Part 11 requirements of the building code. Then we have the recycling that's associated with our buildings. That again is also supported, and I didn't quite remember how that animation worked. The recycling aspects of the materials we're using in our buildings are also covered on CalGreen Title 24 Part 11. What I'm going to be talking to you guys about is about operational carbon, what is being produced while we're using and living in our buildings. That's what's covered under the Energy Code Title 24 Part 6. So let's talk a little bit about scopes of work and how that may impact how the project needs to show compliance to the Energy Code. That's what we're going to talk about the rest of our time here today. Now we have different building occupancies. Not all building occupancies are subject to the Energy Code. So I don't know if you guys can see, what the heck is not here? You'll see that laboratories, occupancy L, is exempt from the Energy Code. Occupancy I3, correctional prison facilities, daycare facilities, I4, are exempt from the Energy Code. Also, occupancy C for camps is also not subject to the Energy Code, but every other occupancy is subject to the Energy Code. We just need to know, is it defined as non-residential, or is it considered a multifamily occupancy, or is it considered a single family occupancy such as R3 versus R2, which is considered a multifamily building, versus R1, hotel motel, which is considered non-residential. They're all over the places. So we need to know our occupancy, and if it's a mixed occupancy building, what parts of the building are one occupancy versus another, so we know how to apply the Energy Code. Now let's talk about what's exempt from the energy code. I don't care if that occupancy is subject to the energy code. If the building feature itself that is being altered or amended is part of a qualified historic building, then the envelope features of the energy code will not apply. So we have a building built in 1910. It's a qualified historic building. It's a brick facade with single pane wood windows. I'm going to be making some changes to that building. So that's an alteration. It would be a trigger to the energy code. But because of this exception, the envelope features of that brick, of those single paned wood windows, would not have to meet current code, because within the scope section of the energy code, it is considered and it's as exempt. It does not have to meet the requirements. If you're adding on to a building and you want it to look like the historic building, guess what? That's new construction and will have to meet the energy code requirements without flexibility unless you're using that performance approach. Any envelope feature associated with unconditioned space, with the exception of daylighting for non-residential and multifamily occupancies. Daylighting is when I have a large volume of space that I want to bring in natural light. So we say, hey, in these large volume of spaces with these high ceilings, we want you to bring in daylight. Otherwise, unconditioned envelope features have no energy code requirements of the energy code. They don't have to meet the rated roof requirements, the insulation requirements, the window requirements. Anything in that unconditioned space is not subject to the energy code unless it's that large volume of space in which we'd like to dictate there is skylights and windows and a combination thereof to support those daylighting requirements. If we have a covered process that is not subject to the energy code, so the energy code has some process loads that are subject to the energy code. So, but some are not. And when we say covered, we don't mean it's a process system that's covered by a roof. I have had that mistake be voiced to me by some. It's the fact that it's covered under the energy code and has requirements. So we have requirements for things like refrigerated warehouses. Now, refrigerated warehouses, if they're less than 3,000 square feet, within the code, it says these refrigerated warehouses are not subject to the energy code because they have to meet Title 20, the appliance standards of the energy code. So when we look at the scope of the energy code, it's giving us a lot of clues on how my particular project has to meet or not meet the energy code. If it's a temporary building in response to natural disasters, and if the local authority having jurisdiction, the building department approves, those can be exempt from the energy code, but they do have a time limit. So there are some, it's 180 days or less. And I have had some projects where like, Gina, we're doing this building, but it's only going to be for 5 years. And then we plan on removing it and replacing it. I'm like, oh, 5 years, people are occupying. Yeah, you have to meet the energy code. Table 100.0-A is my favorite table of the energy code because this is in scope, section 100, and it's about how the different occupancies. So here I highlighted the non-residential and hotel motel occupancy section of the table. There's also a single family section. There's also a multifamily section. And then it breaks down the different building features that are subject to the energy code. And I wanted to point out here where it says under envelope for condition, it's saying, hey, this is the envelope that's conditioned. That's what has to meet these mandatory prescriptive performance options, and how the rules change for additions and alterations only if it's conditioned. But here you see under envelope for unconditioned and process spaces, only this daylighting section, which is 140.3C, will apply to those spaces. Here, the HVAC requirements, including ventilation, are only apply for our non-residential and hotel motel occupancies for conditioned spaces. I get a lot of questions about exhaust fans in unconditioned spaces. So this is such a vitally important table, and understanding the scope of the different building features subject to the energy code and where exactly in the code do those requirements live, and especially how the rules change for additions and alterations. So now let's talk about, did I trigger the energy code, and how did I trigger the energy code? So newly constructed buildings, if they're conditioned, have to meet the energy code in their entirety. And the definition of newly constructed is a building that has never been used or occupied for any purpose. So this is a building that, hey, we're building it from scratch. Of course, it wasn't there before because it didn't exist before, and then we're moving in. That's a newly constructed building, has to meet all the requirements of new construction. But this also includes that first tenant of a tenant improvement building. That building might have been standing there for 10 years, waiting to have the first occupant, that first tenant. That first tenant will have to show compliance to the energy code as newly constructed because they're the very first tenant that has occupied that space. And if we had the permit, the original permit, if they went in as cold shell, hey, it's cold shell, we have nothing about the energy code because nothing about this is conditioned. Then 10 years later, that tenant goes in and puts in that HVAC system, and now they're a conditioned space. They have to meet the entirety of the energy code of the current code cycle, not the one that applied 10 years ago when they newly conditioned the space for the first time, including the PV and battery storage requirements of the 2022 energy code. So we really, those of you who do tenant improvement buildings, please, please, please learn a little bit more, take our architect classes about what we need to consider for those building types. Now, additions is when I'm adding conditioned floor area and conditioned volume at the same time to a building. So I'm adding floor area and it has volume, both of which are conditioned. Sometimes it might be one or the other. I'm adding floor area. I might be adding a floor to a large lofted conditioned space. I just added floor area. The volume already existed as conditioned. That is not considered an addition, but an alteration, and the altered features have to meet the energy code. An addition means every feature of that addition, the floors, the walls, the windows, everything that's there has to meet current code. It doesn't mean the existing building to remain as is has to meet the energy code, only that addition has to meet the energy code. A newly conditioned space is when I take an unconditioned space. This is similar to our tenant improvement conversation. So it existed, it was a warehouse built in 1910, and I'm conditioning it for the first time to become an office space. That is considered a newly conditioned building, and that envelope has to meet the energy code as an addition, meaning that walls, the roof, the windows, everything that's there already, but because it's now being maintained with mechanical equipment to maintain a heating and cooling temperature, those features of the building have to meet the current energy code. Get it, it was built in 1910, but you have to meet 2022 requirements for all of those building features. Alterations is when it's not an addition. Gosh dang it, I love definitions like that in the energy code. But it is a building feature that is subject to the energy code, and that's where table 100.0-A is incredibly important. That has energy code requirements and does not have an exception saying, okay, don't worry about this, we're going to consider that a repair. A repair does not trigger the energy code, but the most important thing to understand about a repair, one, it cannot have an alteration trigger in the code, and two, it cannot increase the energy use of that pre-existing feature. So if I repair a window and I went from dual paned to single pane, that is not a repair. That is now an alteration because you have changed the energy consumption of the space by going from dual paned to single paned. So I have a question for you guys. I'm hoping you guys will answer in the chat. This is the fun part about Energy Code ACE offerings. Which project scope is not subject to the energy code? Are you subject to the energy code when you're building a new home? Are you subject to the energy code when you're adding office space to an existing occupancy B building? Are you triggering the energy code when you're replacing windows in a multifamily historic facade? Do you trigger the energy code when you're replacing an HVAC piece of equipment of a historic building? Which one of these, A, B, C, or D, does not trigger the energy code? I have one person saying D, all mechanical equipment. I don't care. There's no such thing as historic mechanical equipment. We'll have to meet the energy code. For those of you who are picking C, and more of you are doing C, yay, it's all about the envelope. And because it's a qualified historic building or just a facade, I have in San Francisco, I might just have a facade that's qualified, but the entire building is not. So sometimes we want to look at the specific facade of the building. Is it qualified historic? Anything you do to the envelope of that qualified historic feature would be exempt. That would never be mechanical equipment. You don't get to keep that old oil furnace because it's historic if it has to be replaced. Okay, now let's talk about what are the different forms we need when we trigger the energy code. Yeah, exactly. Right, Dave? So when you're submitting for permit, you're promising that your design is meeting the requirements of the energy code. And how that is documented is with a certificate of compliance form. That would be a CF1R for single family, an NRCC for non-residential, and high-rise multifamily, and an LMCC for low-rise multifamily. How many of you have actually read those forms? How many of you are like, oh, Gina, I love getting those from my energy consultant and I'm all over it? Not seeing anyone in the chat telling me they absolutely love looking at these forms, and I don't see anyone raising their hand. So these forms are a checklist against what your design needs to include. So that's what we want to talk to you about in this particular session mostly, is how that form gives you so many tidbits of great information that need to speak to how you designed it. And no one should have to read this certificate of compliance except for you, the design architect, to make sure what's being promised in that form is true. And you have it fully documented within that design document. You have a detail that explains and shows the insulation R values. You have a window schedule that supports the specific window specification needed. Your design has to complement the certificate of compliance. The certificate of compliance is not to take the place of your design. It's meant to support it. When we start building our building, then we start putting features into it, and our contractor needs to be aware what they were supposed to do at a minimum. So we have a certificate of installation requirement for every single building feature subject to the energy code, of which the very first thing it says is, what's the date of the certificate of compliance you looked at that you based all of your installed products on? This should be reviewed during specifications and submittal review by the energy consultant to confirm everything that the contractor is proposing for their install is equal or better than the certificate of compliance. Because if it's not, we have to redo the certificate of compliance and hopefully still support that project is compliant to the energy code. We have acceptance testing. This is all about the installing contractor double checking their work and confirming that controls or complicated mechanical equipment are working properly. And we also have verification. This is third party. This is not the contractor. This is someone who's not employed or related to the contractor that's going in and testing specific building features that are required to be tested by the energy code to confirm that the energy savings promised by the energy code is being supported with that project that's finally getting that certificate of occupancy and people are going to start moving in. Now, when you consider the energy code and when you don't consider the energy code, can change the impact to the timing of the project and the cost of the project and the flexibility of the project. Honestly, for years, Title 24, my joke has always been, oh, I wish it wasn't Title 24, because people think 24 hours before they submit for permit, that's when they're going to get that Title 24 document. And they leave it right at construction documents, right as they're going in for their building permit, and they leave on the table having any thought of it during schematic design and design development, and they leave it for construction documents. That is when you have a huge amount of effort of then the entire design team potentially having to redesign, because our energy code is becoming more and more aggressive. And if we have goals such as zero net carbon design, LEED, platinum, et cetera, and so forth, we have to start talking about that way back in schematic design. So I'm hoping all of you, even your simplistic projects, are considering at least engaging your energy consultant at schematic design and have multiple check-ins with the design team and the person who is doing your documentation and your modeling of your building, so that when we go in for building permit, everything looks beautiful, everything is on the same page, so that everything as it starts getting construction, getting built, it's making sense. One of the worst times to find out we are not meeting the energy code is when that building inspector goes, wait a minute, I didn't think you could do that with this current energy code. And then sometimes we have people go, well, the plans examiner didn't say anything about it. Up to the very, very end, we are to meet the building code. And I don't care if your plans examiner didn't catch it. If you are responsible as the designers, and the contractors are responsible as the licensed contractor per the Business and Profession Code, Division 3. But let's do it in a way that supports the project best and minimizes cost and angst as we try and make this all be a beautiful project that goes smoothly. And in fact, the Energy Code has a commissioning process that's dictated for certain building types to help support this. Why we want to talk about this with you guys in this particular session is, why not consider the commissioning process even if you don't trigger it? Why not look at flavors of the commissioning process to help support that the owner's requirements and any project goals we have are supported? So when we trigger commissioning in the Energy Code, which is for all new non-residential buildings, it is not required for additions, alterations, single family, multifamily, or hotel motel. So there's a limited scope of when this is required by the Energy Code, but it's such a great process. We can always exceed the code, especially when it makes sense to the project goals. We're going to have a kickoff meeting. Does everyone know what we're doing? Does everyone know where we're building? Are there any REACH codes, local ordinances, zero net carbon design goals, LEED, et cetera, that we need to be aware of, that needs to be incorporated into the design process? What are the owner's project requirements? What do they want? What's the basis of design? This is the most important document to me, and understanding how the building is meant to function and how it's using energy. And then design review is a special thing that we see under the Energy Code, in which we have another person look at the design before it goes to plan check, so that we have a plan check before we submit it for permit, to alleviate anything that is going to cause havoc by having it so late in the game that we found out something is not meeting code. And we're just helping support that plans examiner. The virtual compliance assistant is a tool that supports the prescriptive forms for non-residential and multifamily buildings. But I want to talk about how you can use the virtual compliance assistant and use the commissioning form to, even if it's not required, set this up and walk through how the virtual compliance assistant helps get all the team on board. You can invite all these different team members to them to participate here on this online platform to help talk about and develop the owner's project requirements, that basis of design. Hey, what do we want to do about design review, whether it's triggered or not? And it's going to make you walk through and have discussions about the energy efficiency goals. Hey, let's talk specifically about the envelope. Let's talk about mechanical. Let's talk about lighting. Let's talk about renewables. There's many building features that it helps you walk through it and not forget, oh yeah, this is something that needs to be discussed. And what does that mean when we talk about the goals of our project, even if this particular process is not triggered by the Energy Code? So we just wanted to share this as kind of a best practice, and that there's a tool for you that can help you understand how to do all of this. And I hope you guys are seeing in the chat that Dave is adding to the conversation here, and also giving some great links to some of these resources that we have available at Energy Code ACE. So that first building step is mandatory measures. Now, I got to tell you, the compliance forms typically don't speak to the mandatory minimum requirements at all. It's expected that you, the design professional, are very aware of what those mandatory minimums are, and you're designing them into the building, and they are to be supported with note blocks. So there's a lot of information not in the compliance forms to begin with, okay? Then we use our compliance pathway, pick which one we want to go, prescriptive or performance. Now, what's the difference between the two? You can use either one. Why is there two, Gina? Well, the prescriptive method is Well, it's simplistic because we look at each building feature individually. How is the envelope showing compliance versus lighting versus mechanical versus renewables? And it allows the electrical engineer who's doing lighting to work in their own little bubble and not coordinate with anyone and go, hey, I'm in compliance. I'm good to go. And the mechanical engineer does theirs. And I got to tell you, usually they leave the poor architect all by themselves with very little support. And the architect's like, well, I have no idea what's going on with my envelope. I'm used to relying on my energy consultant or the mechanical engineer to help me with this. So prescriptive limits how much the design team is actually coordinating with each other. And it doesn't look at the entire building energy use. It's looking at each individual feature against specific line items of the code. And if you cannot meet every single specific line item, you do not pass the prescriptive approach. And that's why most people use the performance approach. The performance approach only looks at, again, the building features within the conditioned envelope. If it's outside the conditioned envelope, it does not get included in the performance approach. But this allows us to look at one trade-offs. Hey, I want more flexibility than the prescriptive requirements allow for envelope, but I'm doing an amazing mechanical system or an amazing lighting system, and I'm looking at an overall energy use at the bottom line of everything I modeled for the building. Now, you're also going to get some additional information when we use the performance approach that you will not get with the prescriptive approach that we're going to talk through with you guys, and maybe help support why you might choose to use the performance approach for certain projects over the prescriptive approach, because what it gives you, the design professional, to help support some of the goals. So that prescriptive approach is very simplistic. It allows all of your team members to work independently from each other. And there are absolutely no metrics such as overall energy use, overall carbon footprint. None of that is going to be included in these compliance forms. Why I do like to use the prescriptive approach, especially for my designers, is it immediately gives you, if you start filling out those prescriptive forms for your envelope, you know exactly where your design isn't fitting in to the prescriptive pathway. And that immediately is telling you, oh, yeah, we don't want to redesign this. The building owner really wants, 90% glass, and the code only allows me 40%. I know that's why we're going to the performance approach. So that performance approach is melding different building features that are chosen by the design team. It requires that the design team must work together. Doing the performance approach without having some check-in calls and check-ins with looking at what are the different design professionals pursuing for their project design is going to be a failure. So this does require more coordination among all the design team to help support that final product. It provides metrics. We have metrics on energy usage and carbon emissions that can be incredibly useful for other programs that might need those metrics for part of showing compliance to those programs. What can be included in the performance approach? So these building features are not included in the performance approach. Unconditioned envelope, any covered processes, electrical distribution, solar readiness when you did not install a PV or battery storage system, design review and commissioning, unconditioned lighting, lighting that's outside, and sign lighting that's anywhere in the building is not incorporated in the performance energy results. What you can include in the performance approach, and there is some mix and match there. This is why this has to be coordinated with the design team and the energy consultant. I can do a performance calculation of just the envelope. I can do it of just the space conditioning system. I can do it of the envelope and the space conditioning system. I get to mix and match here. So conditioned envelope features, space conditioning systems, service water heating, lighting in conditioned spaces, not including dwelling unit lighting of multifamily dwelling units nor hotel motel rooms. Photovoltaics and battery storage are all incorporated in the performance approach with state certified software that we use to show compliance to the energy code. I wanted to touch briefly on the different forms we have available for single family. I already said that would be that CF1R for the certificate of compliance. It would be the perf that would tell us immediately it was a performance calculation. This would be true for non-res and high-rise also, which would be an NRCC. And low-rise multifamily has their very own form called an LMCC, but all of them have perf in the name, telling us it's a performance calculation. Otherwise, for single family, we would have a prescriptive form just for additions or just for alterations, which is different than non-residential high-rise multifamily and low-rise multifamily, in which each building feature has its own prescriptive form. It's all those different little teeny buckets that I'm showing compliance to. Be aware we do have registration requirements for projects that are single family or low-rise multifamily that have HERS measures, and those forms are supported with our one lonely HERS provider we have at this time. When we're using performance software, it does need to be CEC approved software. It can't be, hey, I know how to design software and I can do it myself. No, you can't. It has to be software approved by the Energy Commission. And when we use performance software, we get to use these metrics, okay? So the metrics we're using in the performance calculation for this code cycle, next code cycle, things are changing. This code cycle, it's based on TDV, time dependent value. What time are you using your energy over the course of the day, over the course of the year? It's dependent upon where is it located? Is it in the heating climate zone, or is it in that cooling climate zone? What's the value of the energy being used? Electricity, natural gas, propane gas, renewables. What's the cost associated with that? They also are measuring a source metric. This is a carbon proxy of the hourly source energy that measures that carbon footprint. So we do have the source total metric that we look to when we're trying to see what's happening in terms of that energy use, whether it's propane, natural gas, electricity, renewables, and what does that mean to that carbon proxy of the building? Of all these metrics, it's looking at the design. It's all about the design. So source total is about the design of all those envelope and mechanical features that are using energy and producing energy, such as PV, and storing energy, such as batteries. TDV efficiency is all about what is that efficiency minimum required by the energy code, and it's typically based on the prescriptive requirements. And then TDV total takes into account the efficiency of the building, and then how are we meeting renewable requirements of the energy code when they apply. Alterations do not have the metrics for source energy, nor do they have that total energy metric, because renewables are not required for additions and alterations to existing buildings. So that is one limitation of our performance software. If it is an addition or alteration, we don't have those additional metrics. But one of the tricks I do is I'll say it's a new building so I can get those metrics. So there are ways to get those numbers. So I have a question for you guys. I am replacing an HVAC piece of equipment. What do you think, which pathway supports this project scope? What makes the most sense when we consider the impact of our compliance pathway? Should we consider the prescriptive approach, or do we want to look holistically at the entire building and use the performance approach? Tell me in the chat, what do you think, A or B, for replacing HVAC equipment? Michael is saying B, Ebby is saying B. When you're just replacing the mechanical equipment, you're just looking at the mechanical equipment and it's not holistic. So typically when we just have one building feature that is being altered, we are looking at the prescriptive approach. One, because of the limitations of the performance approach, but you guys know, hey, Gina, you said mechanical only could use performance. You can, but we usually look at the performance approach depending upon the project's goals and holistically, what are we trying to get from the documentation? What would you choose for a new apartment building? Compliance pathway you think makes the most sense to help support the design team for a new apartment building? Put it in the chat. Yeah, now that performance approach is going to make a lot more sense. We want to holistically look at what is everything going on with this building that is subject to the energy code. And then I also have metrics that I can be looking at to help support any goals or measurements I want to make of the building. You're building a new medical office building that's pursuing zero net carbon design, so you need to measure that carbon. And LEED Platinum measuring global warming potential. What compliance pathway It's the only compliance pathway for you for this type of project. Paul has answered quickly that his performance, and the rest of you now are going there too. When you have to have those metrics, you're going to need to pursue the performance approach so that you can meet the program requirements and get the metrics you need to help support that zero net carbon design goal and the LEED Platinum global warming potential measurement. Let's talk about using a compliance form as a checklist. So I decided to pick the single family form just as an example. I didn't know if most of you might be more comfortable with that form. It would look slightly different if we were talking non-res or multifamily, but the basics are pretty much the same. And one thing we want you to be aware of is when you're signing, because guess what? There is a responsible person signature. That responsible person is dictated again by the Business and Profession Code Division 3, which is typically the licensed architect, licensed engineer, or licensed contractor. You are putting your liability on the line when you're signing, saying, hey, everything in this compliance form, the certificate of compliance, is equal or better, is equal or less than what my design is. My design is going to be equal or better than what's supported in the certificate of compliance, which is setting the bare minimum. And that's what you're signing. So if you don't look through these forms and confirm it supports your design, you're taking a risk by signing it. So let's go through some main things that I see that can make a real impact, such as the scope of the work. Here we have a project. It's a brand new single family home, 1,751 square feet. And we want to look at the CF1R and we want to confirm that the project scope supports that this is a new construction building. If it said addition, if it said alteration or existing plus alteration, the rule set underneath the code, the software completely changes and the metrics change. So please confirm the scope is correct. I do know of energy consultants out there. I don't even like to call them energy consultants. I like to call them paper pushers who cheat. And they call a building an existing plus alteration building because that's how they're able to support your design, which is not true and not what's allowed by the energy code. Location and orientation. So the performance approach is all about where is it located in our 16 climate zones and how is the sun going over that particular building at that particular location over the course of a year. When we run our calculations, like if I run a multifamily calculation, sometimes the calculation takes 8 hours to run because it is doing a shot in time of all these metrics we just talked about for every minute of the day, every day of the year. So there's a lot going on here for us to get what is happening energy-wise. Please confirm that the city and the orientation align with what your documents say. A lot of people get the orientation wrong. I always mirror it. I don't know why. It's a fallacy of mine, of which I've totally changed the energy performance of the building by not having the orientation in there correctly. You're going to want to confirm your PV and battery specifics. So here we have on the drawings, hey, we have a 3 kW PV system and it's on the south part of the wall. Okay, I see here that the form is saying 3 kW and it's going to be oriented. The azimuth is between 150 and 270. That is south. Okay, I'm feeling good about this. But it's also in the form saying I have a 5 kWh battery. I don't see that anywhere in the drawings. There's nothing. So here's something that's promised that's going to change all those metrics under the hood of that calculation that are not supported by the design documents. And this is something we really want you guys to be looking for also and make sure the design documents support how compliance is achieved, or go to the energy consultant and go, where did this battery come from? My owner doesn't want a battery. We have to show compliance without the battery. So those discussions need to happen. Or we might say, hey, why did you put in battery? And let's have the discussion how a battery can help not only the energy performance of that building, but its carbon footprint in terms of storing energy. Our specific building features, such as envelope features. I got to tell you, the opaque surface construction, being able to read that can be very difficult. And I always like to support exactly the detail that is supporting that specific building feature. So here I see that it says A3. This tells me on a sheet A3 is where I'm going to see that detail that supports my exterior wall which is promised to be wood framed at 2x4, 16 inches on center, with R21 batt insulation between the framing and an additional continuous R5 insulation on the exterior of the wall. So we see here in our details, I see the R5 rigid insulation on the exterior. I see my R21 within the 2x6. Oh, it's 2x6. Here in this report, it said 2x4. Now all of a sudden, these two don't agree with each other. Can I really fit R21 in a 2x4 wall? These things matter. What's happening now is that insulation is compressed and is not truly R21 anymore. And that's a big deal. Richard is asking, is the degree of orientation on the front of the angle of the plane or the arrow perpendicular to the plane? So it's based on true north and orientation front of the angle of the plane or the arrow perpendicular to the plane. Oh my gosh, Richard, I cannot visualize what you're saying. Dave, architects speak better than I. I'm hoping maybe you can help answer that question. I'm not quite sure what's being explained.
Yeah,
So
I'm not sure either. So I think it'd be best to just probably look at a diagram. If you Google azimuth angle, it'll show you how it's calculated, right? So that's probably the best way to understand how that angle is determined.
also using reference ACE, which Dave has already put into the chat, there is the compliance manuals in both the single family and the non-residential compliance manual. They have a whole chapter on how we figure out that orientation, what's conditioned floor area, that has some great graphics explaining how we determine the azimuth of the building and what is considered front. I wanted to point out here that when we're looking at our opaque assemblies, I already pointed out, the ones that are associated, associated with the R value continuous, but we also have these assembly layers. Don't ignore the assembly layers, because this is going to break down in part how our insulation is interrupted by our framing. So here we see in our attic roof that some of our insulation, it's R19, but it's telling us that R13 of that R19 is interrupted by framing. And then some of it is not because of the depth of that framing member. And these are all important aspects of how we're determining how heat is transferring through this building. Windows, not only do I want you to look for that U factor and solar heat gain coefficient, I need you to really, really be conscious of the source of that efficiency value. If it says NFRC, that means it's going to be an NFRC rated or certified window product. It can't be anything off the shelf. It can't be just anything. It has to be NFRC rated or tested by a National Fenestration Rating Council certified lab. If you have a window distributor or manufacturer telling you, oh, it's just as good as, they're lying, and you can definitely have some issues when that inspector is going out there. Now, I have had some people say, hey, Gina, what the heck is this exterior shading bug screen? I don't have a bug screen on my fixed window. What the heck? These are default, and it's very difficult for us to get rid of these. So this is one of the few times I'm going to say, yeah, we're going to ignore that because it's a default and there's not much we can do about it. And that's why you want to keep that conversation with your energy consultant as you're going through these, to get comfortable with what is it saying about your design and what does your design need to support. When we move on to mechanical, hey, those efficiencies matter, but also the type of equipment. Here we see that they're doing a gas furnace. What if we looked at this CF1R and it said heat pump? Heat pump and gas furnace are not the same thing. And a heat pump is going to give us a completely different source energy score than a natural gas or even a propane gas furnace is going to. So please confirm the equipment type and the efficiency. Those are really going to matter. When we talk about heat pump water heaters, where they're located is pretty important, including, and then also the efficiency. So here we see on the plans, it says it's a NEA Tier 3 rated, but our CF1R gives us a very specific model number. Now, how the software works is it says, hey, you got to give us the model number of your heat pump equipment, and then we will know whether it's NEA Tier 2, Tier 3, or Tier 4. And this means that we really need to make sure the design documents support this model number for it to be appropriate, because just saying NEA tier 3 isn't going to work, because all manufacturers have different efficiencies based on their equipment configurations, and there's no generalization like we have a tendency to have with gas water heating equipment. Let's talk about some, what am I measuring and what can I get out of that performance calculation? So why might we need to even be considering what is being measured? There are many reach codes and local ordinances. This is where cities and counties can decide, I want better than state adopted code, and this is what's going to happen in my area. There's a great website, www.localenergycodes.com. It has some beautiful resources supporting all the reach codes and local ordinances that are adopted in California. Some of them require that the source energy margin be a certain value or greater. So I wanted to point out in these forms, one, you have the actual score itself, and then to the right, you have the margin. So make sure you know what your program is requiring you to document, whether it be the score itself. There are some reach codes that say you cannot have a source score over 20. Ooh, that one's so hard, let me tell you. Or that your margin has to be a certain number or greater. Like San Jose just adopted one that said your margin for source is going to be 8 or greater. That's really hard to do. So here we have a source energy margin of 8.3. Yay, that is fantastic. So when we look at our non-residential multifamily forms, they have the same thing. Just make sure you're looking at whether you're looking at the total value versus the margin. So then we look at, there are some great tables that give us the KBTU, the TDV per square foot per year, which does need to be converted into numbers that are not based on TDV values. Why I love these tables is it tells me where I am with all my different building features in terms of compliance. So right here, I know for space heating, I have some issues. I have some major issues because I have a negative 23.7 compliance margin. But my indoor fans, my windows, and my mechanical systems are doing pretty fantastic. I always like to look at the worst number and the best number and dive into the drawings and the design and see if that's really true, because those are really going to change how these metrics are supported. We have a table that supports energy use intensity that was provided to help support AIA 2030 commitment. Both the single family, non-residential, and multifamily forms support that particular measurement, which is fantastic. When we want to get the CO2 emissions, that's a little bit harder. They don't have that easily supported within the compliance documents, but it is something that's measured and we have access to. So I'm showing you a screenshot of what our compliance software supports when we look at the CO2 measurement to the various building features of that proposed design. That's really what should be matching what you're designing versus what you're being compared to. So when you're talking with your energy modeler, you're going to want to say, hey, I want the CO2 stuff too. Make sure you support that as an additional document to meet the program requirements or the requirements of our building owner or our client to help support measuring that CO2. I have a question for you guys. I have a new single family home in climate zone 10 that's a really hot climate zone and a really cold climate zone. It's equally hot and cold. And they're using natural gas space heating, and they have a carbon emissions of 1.66. What would you do to change, which building features would you change to get a zero net carbon score? So what do you think? So Marissa's saying A, use a heat pump water heater. Robert's saying, hey, I think we need to do all of the above. So this is from our architect class. You guys are going to want to take the architect class if you want a deeper dive in this. And it actually took all of the above to get a 0 score. Just changing to a heat pump water heater was not enough. We also had to add a battery storage system, which is not required for single family. And we had to increase the PVKW beyond what the energy code requires to be able to show that we are a zero net carbon design building. So just the energy code doesn't currently support zero net carbon design, but if that is a goal of the project, there are some extra hoops that have to be jumped through. But the documentation and the calculations being done by the energy code can help you. So this new home in climate zone 10 is not complying. What one building feature would you look at to improve, to turn the table on this? What one building feature is going to make the biggest impact? Attic insulation, water heating efficiency, window efficiency, or the size of the PV system? Which one of these are you going to choose that's going to change things the most? And I'd like to point out the number that's the worst is space cooling, space cooling, space cooling. Thank you, Bert. Attic insulation really helps with our space heating, but window efficiency is really what's going to make the difference for our space cooling numbers. So improving the efficiency of our windows, reducing that solar heat gain coefficient is going to make the biggest impact. So this is how I want to just have you guys aware. These tables are here. They can help you with, if I'm going to change one thing and only one thing to help save energy, help save the planet, help my building owner have a lower utility cost, what would it be? This is what is in part coordinated with the design team and the energy consultant. Whew. I am hoping you guys learned a lot. You can learn more in our architect classes. We love doing these classes. They're so much fun. We have a couple of fact sheets. Dave already told you about the design review and commissioning fact sheet. We also have our designing a single family home to run on clean energy. That's another favorite of mine, I gotta tell you. We have lots of things that have answers on our website through our Q&As tool, but you can always submit questions to us at any time and you get subject matter experts. I answer all the non-residential questions. Brian Selby, who is just as good, if not better than I, answers all of the residential questions. And we also answer Title 20 and all sorts of stuff. You will need to sign up for an account to have that ability, or you can reach out or to me or Dave directly. We would love it if you would use the help desk. And we thank you for today.